All right, so this is the 5th lesson on solving equations, and what we're going to talk about is what to do when you have an equation and there's a variable on both sides of the equation. So everything we've done so far, there's always just been a variable term on the left or on the right. If you look at this first problem here, I've got this a variable over here, and then I've got some over here. So the first thing you're going to want to do with these types of equations is you're going to want to get it so that you've taken care of any parentheses, such as in the distributive property video, which is the 4th lesson on solving equations on this channel. And you're going to want to combine like terms. So in this one, I don't have any parentheses, but I do have a situation right here where I need to combine like terms. So I'm going to go ahead and just write this one the way that it is. And then 4a minus 2a is 2a minus 3. So all I did is combine like terms. Okay, so once it looks like this, now the way I'm about to describe this, you don't have to do it this way. There's actually a lot of choices you have in terms of what you do, but my point here is to give you something that always works, and especially when it's new to you, it's something that you can use and not mess up and not have a lot of decisions and get confused. So what I always tell kids is you go to the variable term that is on the right. In this particular case, it's 2a. So I say, draw a box, make a circle, whatever, around the variable term on the right. And then you're going to do the additive inverse with that. So what I'm going to do is I'm going to subtract 2a from both sides. So I have a 7a here, and I'm going to do a minus 2a here. So what this is it's additive inverse, but with a variable term. In the first 4 videos, we haven't done that yet. We're going to do it right now. Okay? So this is really the big move we're doing here. I'm getting rid of that 2a. So now I have minus 7a minus 2a, which is minus 9a. And then I have minus 3. And then over here I have a minus 3. Okay? So now what I'm going to do is, if you look at this is a 2-step equation. After I've done this part right here, it's no different than the 2-step equation, which is the 3rd video. I'm going to start with my constant term, so I'm going to go ahead and deal with this guy right here. So I'm going to add 3 to both sides. And then you could see that I've done my additive inverse. So what happens with these problems is you end up doing additive inverse like twice like this. You do additive inverse first on the variable term, and then you do additive inverse on the constant term like we usually do. So now what I'm going to do is I'm going to go ahead and do my multiplicative inverse here. And then this is going to be a is equal to 0. And that's it. That's how you do it. So actually, if you look at it, it's only different from sort of once we get to the beginning part. We're past that. You get to here. It's a 2-step equation. Now, what happens when you're dealing with a variable on both sides of the equation is suddenly there's 2 other new situations that will spring up amongst your problems. So I'm going to talk about those 2 now. So let's look at this guy right here. So what I said to do was you got to get rid of all parentheses and you got to combine like terms. In other words, we need it to look just like this before we can start doing the problem. So that's what I'm going to do. I'm going to do distributive property here. So this is going to give me 2x plus 8 equals 5x plus 8 minus 3x. And so that was distributive. Okay. Next, I'm going to combine these things. These are the same things. So I have 2x plus 8 over here. I have 2x over here plus 8. And now this looks just like that. So I'm ready to go here. Now, if I do what I just said to do, which is get rid of that 2x, watch what happens. I end up with 8, because this is 0, so there's no more x terms, and 8. So oftentimes I'll look at kids' work and they'll have like a 0x here. There's no such thing. 0x means there's no x's, it's gone. I get this. So if you get something where you have the same value on both sides of the equation, that's called all real numbers. What that means is that you can stick anything in the place of x into this equation, anything you want, 3/4, infinity, -5, whatever. It'll work. It'll come out true. That's what all real numbers means. Okay? You actually could see that would be the case here because you see I have 2x plus 8 is equal to 2x plus 8. I have the same expression on both sides of the equal sign. So that would also indicate that it's all real numbers. A lot of times kids can tell that right here, so they don't keep going. The next one over here, I'm going to combine like terms. So I have this 5 and this 2. So I have 7x plus 4 is equal to 7 plus 7x. So I'm going to go ahead and get rid of my variable term. 7x minus 7x plus 4 is equal to 7 plus 7x minus 7x. So that's my additive inverse. I forgot to write that here. Okay, so then what happens is if I do 7x minus 7x, that's 0, so it's gone. So I have a 4 here, and over here I have 7x minus 7x, so that's gone. But look at this, 4 is equal to 7, that's not true. So what that means is no solution. And before I end the video, I want to point out, a lot of times what will happen is people will confuse no solution to a situation where it's equal to 0. How do you tell them apart? Well, the best way to tell them apart is to take the problem all the way to the end. Okay? A lot of times what will happen is I'll see these ones partially done and someone will say that it's no solution. Whereas if they kept going with the problem, you'll notice on both of these, I kept going all the way till the bitter end. That's how you really tell the difference. Okay? So that is how you solve equations with a variable on both sides of the equation.